What do we have to do to make things thrive? Not just survive, but thrive. Let's go to space.
All right, it looks like the waiting room has calmed down, so we'll go ahead and get started. I am Tim Alatorre, Chief Operating Officer and Chair of the Board for Orbital Assembly Corporation. And this is our last Friday with Tim for 2021. Today is December the 17th. I've lost track of time. I look at my calendar. December 17th, 2021. And what an amazing year it has been. Before we get to the questions, I just wanted to kind of recap where things have been this year. Beginning of the year, January, we were coming out of complete lockdown. Well, actually, I guess we still were in lockdown, but 2020, which was the year of COVID, and the orbital assembly team had been working remotely, setting up vendor contracts, having the DSTAR fabricated remotely, doing engineering reviews remotely. Everything was remote. And coming into the beginning of this year, we were having delays due to supply chain issues, and we weren't sure when the DSTAR was going to be finished. We were actually hoping to have the DSTAR ready, tested, and demonstrated by, I think at that time we were saying like February or March. And supply chain issues, Port of LA issues just caused delay after delay after delay. But we kept pushing forward, and then we had our hugely successful first assembly event in February with our first capital raise on Net Capital this year. And we sold out $1 million within a week after our live event. And that was just amazing. That propelled us so far this year. And so, thanks everybody who invested in that first assembly raise. And then coming out of that, we got the DSTAR in our Fontana facility. We set up the Fontana facility, DSTAR sitting behind me right here. And we had the fun process of doing final integration and test runs, and Tom Spilker and Rob Miyake and Tim Clements and myself, and we had a bunch of additional workers that were there so our corporate headquarters has been and still is up in the Sacramento area, which is where I was based out of at the time, and I was commuting down to LA every week, and we were down there in Fontana for months, running through testing and making adjustments on the design and the automation systems. And then we had our live event in June, which a lot of you who are watching were probably there or are familiar with. And that was just fantastic. Got to meet so many of the investors and supporters. That was just a great way to kind of celebrate and end this DSTAR program, where we rolled off out of this machine 2 tons of steel in a record-breaking time at the live event. During our trial runs, it was taking us over an hour to build the truss, and we made some final adjustments and were able to cut that time in half. We were down to 24 minutes, which was just mind-boggling. And once we get it fully automated with the P-Star, we'll be able to build structures in space in record-breaking time, which is exciting when you think about how long, the decades it took to build the International Space Station, and how every single bolt on that truss, there was a spacewalk and somebody in an EVA suit out there, trying to wrangle their tools and put these bolts together in very hazardous conditions. I think DSTAR is a program that, it's not in space, it's not that flashy, but for us internally, it's a huge milestone. We're so excited with what DSTAR represents and the next steps that it's going to enable. And then coming out of that, this year we've really been working on our industry partnerships, Rogue Space Systems and their Orbots. Excited to announce that we are actually we've had a collaboration, we've been working together on partnerships. We've actually made our first deposit now on our Orbots, the first drones for our 2023 mission with Rogue Space, and so they are working now on building our first robotic drones for us, which is super exciting. And other industry partners, we've had multiple meetings with CR Space this year, talking about the Dream Chaser and how we can integrate that with our program, and not just the P-Star, but obviously moving on to Voyager and that program. And then other partners like Paragon and Environmental Control Systems, Arizona State University, Kai Stotts, who is now one of our advisors, who works at the SAM project there at Biosphere 2 for ASU, and we posted some pictures on Twitter earlier this year when we were out there. Really excited to have that collaboration with ASU. And actually, our team is working with, we'll be working with this coming semester, a group of students at ASU who are going to be doing a project with the gravity ring. We're partnering with them, and they're going to be doing some analysis and doing some research with the gravity ring design, which is super exciting. Not only from a standpoint of having them kind of assist us in a way with some of the dynamic modeling, but also as a way to give back and have our engineers working with those students. It's going to be really, really exciting. This year, like I mentioned, we brought in some new advisors, which we've gone over in previous calls. And then also we've been maturing and augmenting our corporate governance. So we've brought on several new board members this year, Rhonda Stevenson and Bill Toski and Drew Wall. And Bill and Drew are our first independent directors. And as we move towards being a public company and IPO, those independent directors become really crucial, not only in guidance and governance of the company, but also just in complying with SEC regulations and allowing us to get to that point where we can be listed on NASDAQ and become a publicly traded company. So that's really exciting. And then Drew Wall in particular, you'll learn more about him as we start to share more information about him, but he has a long track record with raising capital and working with venture capitalists. And so he is really helping us, getting prepared now as we exit out of this second net capital raise and go into our first large institutional raise, and connecting us with those investment dollars, which will then kickstart us into 2022. And then capping off this year with our second net capital raise. And thank you again to everybody who is invested in that. Really, it's exciting for us to be able to come back to net capital and work with them again and make our stock available to our supporters once again. I'm not sure if it'll be the last time, definitely the last time for this year. But as we move into these investment dollars and get into these other rounds, things with the company are going to be maturing and accelerating. And it was really important to us, especially the founders, but just the executive team of Orbital Assembly, that we were able to get our supporters kind of in on the ground floor and give you that opportunity. So really thankful for everybody who's participated. And hopefully a lot of you have been able to claim your investor gifts. And as we get into these subsequent closing rounds, we'll send an email reminding everybody when your kind of gift becomes available to be claimed. And it's a small token. We really owe you a lot more, and we're working on that. We're working on getting space hardware and space stations available to where you can actually come and go to space with us. So looking forward to 2022. So many exciting things are happening. My mind actually right now is just racing. I just got off of a fantastic call. We have been looking for months for a vendor for a particular system, and I can't go into details, but our executive team has been basically doing a global search trying to find this person, and we weren't even sure if they existed. We had a feeling they existed based on the clues that we've been gathering, and we found them, and just got off of a really exciting call right before this with them. And so looking forward to being able to make an announcement about that. But it's going to be I don't want to say game changing, but it's a serious step forward for not just us, but commercial space stations in general. And the fact that we were able to track them down, I feel kind of like should be part of a movie. Definitely should be a scene in a movie. When they make a documentary of our story, those will be part of it. But we're also in the final. So looking forward to 2022, I really want to be able to announce our launch provider, and we're in the final negotiations for that. So that should be coming soon. And then coming into 2022, starting to build the P-Star and Gravity Ring, which we're now, we finalized the architectural design of those systems, and now starting to work on some of the finite element design and the detail engineering, so that can then go to fabrication. And obviously building out our staff and our team. We brought in a lot of people this year, a lot of different support people and engineering individuals, and we're going to keep continuing to grow that team. And then we've actually, looking towards Gravity Ring and P-STAR, we're working on finding and building out a new facility for that process. And so we've been, over the last number of months, doing a nationwide search and examining different areas, and we've got it narrowed down to final selection here, and we're in negotiations now to kind of graduate and move up to a larger facility, which we hope will be our, I would say, permanent home. The way aerospace works is you kind of have little hubs in different areas, as we have vendors and suppliers around the country, but that'll most likely be the new corporate headquarters and our permanent home. So that should be an announcement coming up here and hopefully the first quarter of 2022, as we're in kind of the final processes of that. So a lot of exciting things happening. 2021 has been a fantastic year, and thank you all for being a part of that. So with that, we'll now transition to questions. If you have a question, feel free to drop it in the chat, or if you want to ask your question live, you can just use the raise your hand feature on Slack, which I think, yep, it's available. There's a little reactions button at the bottom. Click that and you can raise your hand. Okay, so first question today comes from Athena Gibbons, who's asking, what is the schedule for performing the first orbital assembly? Now, I think you mean orbital assembly as in the verb, the noun, or an adjective verb orbital assembly, not our name, the proper noun orbital assembly. So the first on-orbit assembly will be the Gravity Ring mission in 2023. We're planning to launch on the end of 2023. And so that will be the P-STAR, which is the Pioneer class structural truss assembly robot, which is the flight version of the thing sitting behind me. And that will build the circular gravity ring, which will then spin up and create artificial gravity. So that's 2023. Jonathan's asking about the investor gifts delivered to Switzerland. Yes, that was brought to our attention that the international shipping on those has not been functioning, and we are working with our supplier, our vendor on that to try to get that sorted out. So sorry for the delays on that. We're in the holiday season, and shipping and logistics are just not an easy thing right now. So we were trying to work through that. Let's see, Marco asks, let's see. So he's asking about some of our former executives and people who used to be in the company, and talking about some of the information that's floating around the internet about that. And unfortunately, the way our legal system works, and just confidentiality and disclosure requirements and such, there's actually very little I can say about that topic. I can say that former executives are still shareholders, and Rhonda Stevenson has been our CEO since April. She's been doing a fantastic job, and that's about all I can say, unfortunately, Marco. And I know how secrecy and not sharing answers, people jump to the worst possible conclusions, but sometimes it's just the way it works. So I can't say much more about it. Let's see, any other questions? Chat is quiet today. Oh, here we go. Kyle Sims, will the investment round be open until the 10th? Oh yeah, thanks for reminding me about that, Kyle. I think we will keep it open to the 10th, given kind of where things are at right now. But I'm not sure if we'll extend it past that. So you have 20-something days to get your investment in. And I'm hearing some, there we go. Okay, I'm hearing some background noise. We're gonna mute people. Chuck's asking more about the gifts. How do the gifts work? If I invest in January, is it still available? Yes. Anybody who invests in this net capital round, if you meet those benchmarks, then we'll make sure that gift gets to you some way or another. And the way it works is after net capital provides us the records of who our investors are, we feed that into our system, and then you go and you have to enter in some information just to prove who you are. And then you go to our shop, and it gets sent out to you. So super simple. Okay, well this could be a quick call. Oh, here we go. Let's see here. John is asking, for the modules where people will work and live, what kind of air filtration will be used? Does this already exist? That's actually a fun question, John. So earlier this year, earlier this year, basically anything before right now, it was earlier this year, right? Not too long ago, within the last couple months. I was actually at a vendor who we're considering to provide our environmental control and life support systems. And all of that technology exists. There's a lot of different systems involved with ECLSS, as it's called, environmental control and life support. Air filtration is part of that, which is actually the easiest part. You just basically drop on a HEPA filter and you're done. The more challenging parts of the ECLSS system come into play with carbon dioxide scrubbing and oxygen replenishing and making sure that all your gas levels remain constant. In gravity environments, there's a bit of an aid in that you have some natural kind of convection that happens and circulation of the air. In microgravity environments, and because gases have different densities, right? In microgravity environments, you can actually develop pockets, CO2 pockets, where you have certain gases that aren't mixing properly, and so you could think everything's fine, and you're hanging out in one of those pockets and actually, asphyxiate because you don't have enough oxygen. So there's different ways to design that to make sure the airflow is consistent. So all that's been worked out. It's been in operation on ISS and the Dragon capsule and Soyuz, and I mean any spacecraft that's flown in the last 60 years has had some sort of system to provide for that. I mean even like submarines have systems to deal with that because it's the same sort of problem, right? So we're working with established vendors who have flight heritage in space technology. There's different what's called technology readiness levels. You might hear this TRLs, and all of the environmental control and life support systems are TRL 9, which means that they've actually flown and been proven. And so there's in addition to like filtration, there's making sure your gas levels are correct, carbon dioxide scrubbing, carbon monoxide, fire detection, fire suppression. Maintaining proper humidity and temperature, all those are kind of all in that wheelhouse. Aiden, I'm sorry, I didn't see your hand up there. I'll pin you here, and you can. Let's see here. There we go. Go ahead and unmute and ask your question. You're still muted, Aiden.
Oh, will the Pioneer class station use thrusters or gyroscopes to spin and despin?
Yeah, that's also a fun question. So for those of you who don't know, gyroscopes are actually in use on a lot of spacecraft. And basically what you have is an object, usually it's like a metal disc or a hoop that's spinning, and it has a certain amount of mass to it. And then by changing, you have little motors, you put a force on that gyroscope, and because of the way the physics work, that plane wants to maintain its position. So because you're in space, as that plate wants to move back, it causes the spacecraft to move in the opposite direction. Now, one of the problems with gyroscopes is you have a limited degree of movement that you can accomplish with them before what's called saturation occurs. And that's where you've reached the limit of how far that gyroscope can move in the spacecraft contrary to it, and you basically hit the physical limit of the gyroscope. So they actually had that problem on the Apollo spacecraft. They would have gyroscopic lock or saturation on those. And the way you overcome that, and it actually happens on ISS as well, the way you overcome that is you lock the gyroscope, then you fire the thrusters to basically reset the gyroscopes, and then you let them go free again. So for spinning and de-spinning the station, gyroscopes really don't give you enough angular momentum to actually make that motion possible. So we would use thrusters. In a microgravity scenario with the station, when it's not in rotation, you theoretically could use gyroscopes to maintain orientation. But since we already have thrusters involved and they already can kind of do the job, we're probably just going to use thrusters for that as well in the microgravity configuration. But really fun question, and actually that was when I first got into with the team looking at how we were going to do all the control systems. That was my thought. Let's see if we can use gyroscopes, because it's basically they're electrically powered. There's no propellant needed. You can run them all with solar panels, so it's kind of a renewable, easy way to do it. Next question is from Kyle, and he's asking, So there's one here from Benny. He's asking, can you use the P-star for a fuel depot? Yeah, absolutely. We could. So the P-star is the machine that is building the gravity ring and other structures. So if there was extra propellant on that, you could have craft docked to it to refuel. And actually, the Rogue Space LoRa drones will essentially be using the P-star as a fuel depot or propellant depot, because they'll come back to the P-star to dock to recharge their batteries. And then there's also, so if you had a craft coming back to dock, you could also transfer propellant at the same time as transferring electrical energy. So yeah, totally could do it. Right now, we haven't found a customer for that use case. If someone came to us and wanted that service, we could provide it. We are looking at using Pioneer Station, however, as a propellant depot for some other spacecraft, not human-rated spacecraft, but other drones and robotics that could then come back to Pioneer to refuel after performing some mission. Kyle's asking if there's any sort of corporate connection to the Gateway organization. No, none whatsoever. And then Don's asking, do you have designs for rotating fuel stations to create fuel flows from inside supply tankers to outside rockets? Don, I can't talk about what theoretical designs we have. That's not how companies work. Yeah, we have actually. We've talked about that, and we have some designs that we've been working on. In fact, there's an image. It's been floating around. The Voyager propellant depot is a concept we've talked about, where you basically could convert the Voyager modules, which are pressurized for human habitation, just make those pressurized propellant tanks, and you could refuel an entire fleet of spacecraft. The nice thing about having rotating fuel stations, not only like you're saying, where you could kind of use that gravity to push the fuel from a tank to the vehicle, which most propellant transfer, if you think about like terrestrial applications, isn't gravity flow. It's usually mechanically pumped, right? And that actually, in some ways, gives you a little bit more freedom, because you can pump it anywhere you need to. You don't have to have that vehicle docked to the outer rim of the station. And docking and undocking on a rotating body is, I wouldn't say impossible, but very, very complicated. We would not recommend it. So all of our craft on our rotating stations, they dock at the axis of rotation, and that way you're not trying to catch up with the ring that's moving around. So by using a pump, you can get the fuel from those tanks to the craft. Now, the nice thing about gravity, though, if in a microgravity scenario with propellant tanks, you have the situation where as you start to drain fuel, you can't create a vacuum inside of that tank, right? So you end up injecting an inert gas into the tank to make up the volume difference, right? And so then the challenge happens, well, okay, now I've got like gas bubbles floating around. So in gravity environments, all the fuel settles. And it actually just takes a small amount of gravity, right? So like if you have a spacecraft, you just accelerate it before you start drawing fuel off of that tank. And that whole process, this ullage is the term. You don't want gas, like an inert gas, not a propellant, getting into your fuel lines. So a gravity rotating station actually eliminates that problem, because you can have all your outlets where you're pumping the gas or the propellant from on that direction where the gravity or those acceleration forces are pushing that propellant. And keep in mind, on a rotating body, it's not at the back of the module, it's at the outer rim, right? Because all the forces are radially out. Anyway, so yeah, a fun thought experiment. We definitely we put images out there about it, and something we're considering. Even not on a Voyager scale, but if you go smaller to like a Pioneer class station, having propellant tanks on there for refueling as well makes a lot of sense. And like I said, we've been having some conversations with potential customers and about providing that service. Let's see here. Chuck's asking, not sure if already before, the modules seem to be so big, so will the biggest SpaceX rocket be the only way to get them up there, the actual habitat modules? So Chuck's probably referring to the renderings of Voyager Station that are out there. And the renderings that are available right now show a 3-story structure, which is it's approximately a 12-meter diameter habitat. I can't remember what the actual dimension is. I haven't worked on Voyager in a while. I've been, head down on Pioneer, but we've actually decreased the module size slightly to work within the existing Starship fairing. So at some point when we circle back around to updating our Voyager imagery, you'll see that we've actually decreased the module size. Now, we have done some really cool things with the Voyager architecture to where we are not losing overall volume on the station. So stay tuned for that. But we've been trying to make everything fit within existing launch vehicles and not having to rely on future concepts or having launch providers modify their platforms for us. And those early Voyager concepts, we were actually considering trying to remember what am I allowed to talk about. We've had conversations with launch providers to modify their rockets to be able to use that module, the habitat module, actually as a part of the rocket. So it wouldn't have to fit inside a fairing. It essentially becomes the fairing. You put a nose cone on it as a way to get those large modules to orbit. And it is possible. The math all works out. The challenge is the time it would take to get that rocket modified and certified. And we, looking at our time frame of having Voyager start construction in 2025 and operational by 2027 and Pioneer operational in 2025, we just can't afford to have a rocket service provider, a launch service provider, spend 4 years validating a new hardware, right? We just don't want to make that time sacrifice. So we've actually modifying everything to fit within either launch vehicles are flying right now or they're going to be flying before we're ready to go. So that's kind of the shift that's happened there. And nice thing about that is it also brings down cost, which that's a big thing. We're trying to keep the cost down to get all of you to space. So that's a shift. Stay tuned for future imagery. Probably is not going to happen. We're not going to get new Voyager imagery out there for some time. Again, because we're all hands on deck for the immediate Pioneer station. Let's see. Matthew's asking, when pumping fuel, how is the mass relocation accounted for with regards to the motion of the station? I.e., is there a danger of station wobble? That's a really fun question. If you've ever had your tire balanced on your car, or if you, some people messaged me saying they're trying to get into the waiting room. We'll let them from the waiting room. Or if you've ever had a bike tire, like you crashed it and kind of got bent a little bit. Probably the common analogy thing people most have the experience with would be a car tire, right? You get it balanced because if the tire's off balance, you do get some wobble. So that is a challenge. If you have a mass not just being like ejected, like a dream chaser being detached, or like Matt's talking about here, moving propellant or people, that can induce a wobble. So we do have a system that we've developed on an architectural level. The actual mechanical engineering hasn't been completed yet, which would balance out the station. And it's actually fairly trivial to do. It's more of a software issue. You have accelerometers that measure that wobble, and then you have a counterbalance that is then positioned or moved to offset that. That's about as much as I'll say on that topic right now. Benny's asking, could we use mag lifts to propel our supplies into space? There are companies that are looking at using, and I think what you're talking about is like a kind of like like using electromagnets to accelerate an object to hypersonic speeds to reach escape velocity. You could, so there's companies that are looking at doing that actually on the moon because there's no atmosphere and it's relatively easy. The challenge with leaving Earth, deep gravity well, and the oxygen or the atmosphere is pretty thick. So you end up with, the velocity of the object leaving the barrel of that, launch device would cause it to disintegrate more than likely. Coming from the lunar surface, I think that's probably be more plausible. Let's see, we've got some reactions, and then Aiden, let me pass back to you here. And go ahead and unmute and ask a question.
Will any parts of the DSTAR be reused in the future?
So the DSTAR is the bright yellow thing sitting behind me. I can't promise anything. For my part, I've spent so much time and so many bloody knuckles from DSTAR. I'm happy just to see it sit in the museum. There potentially could be some use cases for it, and our business dev team has come up with some really imaginative ways to use DSTAR. I think in my mind, those become distractions from what we're trying to do on orbit. I think DSTAR as a program served a very important purpose, and we learned a lot from it. But I think its time has passed, and we'll have it in a display, and you can come sit on it and play around with it. Yes, Tom Smilker, our CTO, chimed in here. One thing I left off on the electromagnet launch systems is just the acceleration. And here, I'll take you off here, Aiden. You have to stick around for this one. Thanks for your question. Yeah, so Benny was asking about that in the context of like supplies. The acceleration for supplies, especially if they're inorganics, probably isn't as big of a concern. But if you're launching anything organic, the acceleration levels would, no, you probably wouldn't survive that. So, okay. Well, with that, we've reached the end of our mark here. Just again, thank you all so much for being part of these calls for this year. We've done, I've lost track. When it comes out on YouTube, you'll see the count. I think we're at like 12 or 13 or something like that. And it's been a lot of fun. Really appreciate your input and your questions. And our next call will be in January. If you're subscribed and you got the notice on this, then you'll get the reminder. And yeah, happy holidays, everybody, and I look forward to a great 2022. Thanks, everyone.